I've been working on Japanese cars for 14 years. Toyotas, Hondas, Subarus, thousands of them. And 5 years ago, I had a conversation with a retired Toyota engineer from their Tahara plant who moved to California. He asked to see my service records. When I showed him the intervals I was following, the ones printed in every American owner's manual, he looked confused. Then he said something I'll never forget. These intervals are not what we use in Japan. They are much too long. Your engine will not stay clean. That conversation sent me down a path that completely changed how I maintain these cars. The average Toyota in Japan routinely exceeds 300,000 miles. The same model in America often needs major work before 200,000. Same engineering, different maintenance approach, and by the end of this video, I am going to show you the exact interval that prevents nearly every catastrophic engine failure I've seen in high-mileage Hondas, and why the oil change advice you've been following is setting you up for a repair bill most people never see coming. Before we get into the specific intervals, hit subscribe right now, because I post one video every week on exactly this kind of information that dealerships will never tell you, and that keeps these Japanese cars running long after the warranty expires. Here's what you need to understand about why American maintenance advice is different from Japanese maintenance advice. It's not a conspiracy, it's an incentive problem. American dealerships make very little profit on oil changes and fluid services. A typical oil change makes the dealer maybe $15 after labor and overhead. But a new engine? That's $8,000. A transmission replacement? $5,000. The service department's profit center is not maintenance, it's repairs. So when Toyota Motor North America prints a maintenance schedule for the American market, they are not optimizing for maximum vehicle lifespan. They are balancing customer convenience, competitive positioning against other brands, and dealer service revenue. The interval they print is the longest interval the engine can survive without failure during the warranty period. That's a very different goal than maximizing engine life. In Japan, the philosophy is reversed. Maintenance is not viewed as an expense you minimize. It's viewed as the insurance that prevents catastrophic loss. You spend small amounts continuously to avoid spending large amounts suddenly. Every fluid service, every filter change, every inspection is designed to keep the component in near original condition for as long as physically possible. That difference in philosophy is why the same Camry engine in Tokyo looks clean inside at 250,000 miles, and the same engine in Dallas has sludge on the valve covers at 120,000. Let me start with the single most important interval that almost no one follows correctly. In the United States, Toyota and Honda both recommend oil changes every 10,000 miles if you're using synthetic oil, and following their maintenance minder systems. Honda's system will often stretch it even further. In Japan, the recommended interval for the same engines is 5,000 kilometers. That's 3,100 miles. When I asked the engineer why the difference was so extreme, he said, "We don't trust oil to stay clean that long, even synthetic." Here's the specific recommendation. Change your oil every 5,000 miles, not 7,500, not when the maintenance light comes on. Every 5,000 miles, no exceptions. Use full synthetic oil that meets the exact specification in your owner's manual. For most Toyotas, that's 0W20. For most Hondas, it's 0W20. For Subarus, it's usually 0W20 or 5W30, depending on the engine. The weight matters. Do not use 5W30 in an engine designed for 0W20 just because it's on sale. Here's why this matters at the component level. Oil does not just lubricate, it also removes heat and suspends contamination. After 5,000 miles, even the best synthetic oil has accumulated enough combustion byproducts, moisture, and metal particles that it stops protecting effectively. The detergent additives that prevent sludge formation start breaking down. The viscosity modifiers that keep the oil flowing at cold temperatures degrade. And once sludge starts forming on internal engine surfaces, it blocks oil passages, causes hot spots, and accelerates wear on the camshafts and timing chain tensioners. I've torn apart dozens of high-mileage Toyota and Honda engines. The ones maintained on 5,000-mile intervals look almost new inside at 200,000 miles. Clean valve covers. No varnish on the pistons. Timing chains that still have factory tension. The ones maintained on 10,000-mile intervals show visible sludge at 80,000 miles. By 150,000 miles, the oil passages are restricted. The variable valve timing systems start failing. The timing chains stretch. All of that comes from oil that stayed in the engine too long. I worked on a 2011 Honda Accord V6 last year with 287,000 miles. The owner bought it used at 60,000 miles and changed the oil every 5,000 miles with full synthetic for the entire time he owned it. When I pulled the valve cover to replace a gasket, the inside looked like it had 40,000 miles on it. No sludge, no discoloration. That engine will run another 200,000 miles. Compare that to a 2013 Accord 5.6 I saw 2 months later with 142,000 miles. That owner followed the maintenance minder system and changed oil every 8,000 to 10,000 miles. The valve train had visible sludge buildup. The variable valve timing actuator was sticking. The repair cost was $1,800 just to clean the system and replace the actuator. An oil change costs $60 if you do it yourself with quality synthetic, maybe $90 at a quick lube shop. Over 100,000 miles. The difference between a 10,000-mile interval and a 5,000-mile interval is 5 extra oil changes. That's $450. The engine work you avoid is never less than $2,000 and can easily exceed $6,000 if the damage spreads to the timing system. The math is simple. You will not hear this from a dealership because they lose money every time you come in for an oil change, and they make money every time you need engine work. The incentive is backwards. Next is transmission fluid, and this one surprises people because most modern Toyotas, Hondas, and Subarus have transmissions that are labeled as lifetime fill or sealed for life. Honda doesn't even put a dipstick in most of their current transmissions. The implication is that you never need to change the fluid. In Japan, that is not how these transmissions are maintained. The fluid is changed on a strict interval regardless of what the American manual says. Here's the exact recommendation. Change your automatic transmission fluid every 30,000 miles, not a flush, a drain and fill. Flushes force new fluid through the system under pressure and can dislodge debris that clogs solenoids and valve bodies. A drain and fill removes about half the fluid, replaces it with fresh fluid, and lets the transmission mix it naturally over the next few hundred miles. For continuously variable transmissions, which Honda and Subaru both use extensively, the interval is even shorter. Every 25,000 miles. CVTs are less tolerant of degraded fluid than traditional automatics. Use only the transmission fluid specified by the manufacturer. For Toyota automatics, that's Toyota Genuine ATFWS. For Honda automatics, it's Honda ATFDW1. For Subaru CVTs, it's Subaru High Torque CVT fluid, or Subaru Lineartronic CVT fluid, depending on the model year. Do not use universal fluid. Do not let a shop talk you into using whatever they have in bulk. The fluid formulation is specific to the clutch materials and valve body tolerances inside your transmission. Here's the mechanism. Automatic transmission fluid operates under extreme pressure and temperature. It doesn't just lubricate gears, it hydraulically engages clutch packs, operates solenoids, and controls shift timing through pressure modulation. As the fluid ages, it oxidizes. The viscosity changes. Friction modifiers break down. The fluid starts to lose its ability to transfer pressure smoothly and protect clutch surfaces. Once clutch material starts wearing, it contaminates the fluid with particles that accelerate wear on everything else. The valve body solenoids get dirty. The torque converter clutch starts slipping. And once a transmission starts slipping, the heat generated degrades the remaining fluid even faster. It's a cascade. CVT fluid is even more sensitive because the belt or chain is clamping against the pulleys with tremendous force. If the fluid loses its friction properties, the belt slips. That generates heat and metal particles. Within a few thousand miles, the CVT is damaged beyond repair. I've rebuilt transmissions for over a decade. I can tell you exactly what the inside of a transmission looks like based on how the fluid was maintained. A Toyota 8-speed automatic transmission with fluid changed every 30,000 miles will hit 250,000 miles with clutch packs that still look factory. The fluid comes out pink and clean. A transmission with original fluid at 100,000 miles has fluid that comes out dark brown, smells burnt, and leaves residue on your hands. The clutch packs are glazed. The valve body has varnish buildup. I saw a 2016 Subaru Outback CVT last year with 140,000 miles. Owner changed the fluid every 25,000 miles. The CVT still shifted smoothly and the fluid looked nearly new. Compare that to a 2015 Outback with 89,000 miles and original CVT fluid. The transmission was shuddering on acceleration. Subaru wanted $7,500 for a replacement CVT. The owner had saved maybe $600 over the life of the car by not changing the fluid. That's not a savings. All right, that's a delayed bill with interest. A drain and fill costs about $150 to $200 at an independent shop, less if you do it yourself. Over 200,000 miles, you'll do it 6 or 7 times. Total cost is around $1,200. A replacement transmission starts at $4,000 and runs to $8,000 depending on the model. I've never seen a transmission that was maintained on a 30,000-mile interval fail before 300,000 miles. I've seen dozens of sealed-for-life transmissions fail before 150,000. The reason manufacturers label transmissions as lifetime fill is not because the fluid lasts the lifetime of the vehicle, it's because the fluid lasts the length of the warranty period, and calling it lifetime fill eliminates a maintenance item that makes their cars look more expensive to own than the competition. It's marketing. It is not engineering. If you want the complete Japanese maintenance schedule for your specific Toyota, Honda, or Subaru, organized by mileage with exact fluid specs and part numbers for every service, I've put together a free maintenance checklist that covers everything from oil to coolant to differential fluid. It's in the description. Grab it before you leave. Third is coolant. Most manufacturers now recommend long-life coolant that supposedly lasts 100,000 miles or 10 years. Toyota's red long-life coolant is rated for 10 years. Honda's blue Type 2 coolant is rated for 10 years or 120,000 miles. The Japanese maintenance schedule does not wait that long. The interval there is 5 years regardless of mileage. Here's the specific recommendation. Change your coolant every 5 years or 60,000 miles, whichever comes first. Use only the coolant specified by your manufacturer. Toyota vehicles use Toyota Red Long Life Coolant or Pink Super Long Life Coolant, depending on the model year. Honda uses Honda Type 2 coolant, which is blue. Subaru uses Subaru Long Life Coolant, which is green. These are not interchangeable. The formulations are engineered for the specific metals and gasket materials in your engine. Do not mix them. Do not top off with universal coolant. If you don't know what's in your system, drain it completely and refill with the correct fluid. Coolant does not just prevent freezing and regulate temperature. It also protects against corrosion. Every cooling system has a mix of aluminum, steel, copper, and rubber components. As coolant ages, the corrosion inhibitors deplete. Once they're gone, galvanic corrosion starts. Aluminum corrodes first. The water pump housing develops pits. The radiator end tanks crack. The heater core starts leaking. Rubber hoses degrade from the inside out. You don't see the damage until a hose bursts or the radiator starts leaking. By then, the contamination has spread through the entire system. Replacing a radiator, water pump, hoses, and heater core will easily cost $1,500 to $2,000. And if a hose bursts while you're driving and you overheat the engine before you notice, you can warp the head or blow the head gasket. Now you're looking at $3,000 to $5,000 in engine work. I inspected a 2008 Camry with 223,000 miles last year. The owner changed the coolant every 5 years like clockwork. When I pressure tested the system, it held perfect pressure. The coolant came out clean. The radiator had no corrosion. And compare that to a 2010 Camry with 130,000 miles and original coolant. The overflow tank had rust sediment at the bottom. When I drained the radiator, the coolant was brown. The water pump was seeping. The lower radiator hose was soft and spongy. That owner was about to have a failure. The coolant service would have cost $120. The repairs were going to be over $1,000. A coolant drain and fill cost around $100 to $150 at a shop. You can do it yourself for about $40 in coolant and an hour of your time. Over 200,000 miles, you'll do it 3 or 4 times. Total cost is maybe $500. The cooling system repairs you're preventing start at $1,000 and go up from there. I have never seen a cooling system maintained on a 5-year interval suffer a corrosion-related failure before 250,000 miles. The reason manufacturers stretch coolant intervals is the same reason they stretch all intervals. Longer intervals make the vehicle look cheaper to maintain in comparison guides, and cooling system failures usually happen outside the warranty window. By the time your radiator cracks, the manufacturer has no liability. You're paying for the repair, they already sold the car. Fourth is the cabin air filter and engine air filter, and most people ignore these completely. The maintenance reminder systems in most cars don't even track air filters. You're supposed to remember to ask for them. Most people don't. In Japan, these filters are inspected at every service and replaced on a strict schedule regardless of appearance. Here's the recommendation. Replace your engine air filter every 15,000 miles. Replace your cabin air filter every 15,000 miles or once a year, whichever comes first. Do not wait until they look dirty. Do not let a shop talk you into cleaning them and putting them back. Filters are depth loading. The contamination is inside the media, not just on the surface. A dirty-looking filter that's been blown out with compressed air is not clean. It's just dry. The engine air filter controls how much dust and debris enters your engine. A clogged air filter restricts airflow. That reduces power and hurts fuel economy, but that's not the real problem. The real problem is that a saturated filter stops filtering effectively. Fine dust particles bypass the media and enter the intake tract. That dust makes it past the throttle body, through the intake valves, and into the combustion chamber. Now you have abrasive particles between the piston rings and cylinder walls. The rings wear. Compression drops. Oil consumption starts. I've seen engines with less than 100,000 miles that are burning a quart of oil every 1,000 miles because the rings are worn out. The cause was a neglected air filter that let dust into the cylinders for years. The cabin air filter controls what you breathe inside the car, but it also controls airflow through the HVAC system. A clogged cabin air filter makes the blower motor work harder. That burns out the blower motor resistor or the blower motor itself. A blower motor replacement costs $300 to $500 depending on the car. And I've also seen clogged cabin air filters cause evaporator core icing because the restricted airflow drops the temperature below freezing. Once the evaporator ice is over, your air conditioning stops working until the ice melts. If it happens repeatedly, it can crack the evaporator. Replacing an evaporator requires removing the entire dashboard. That's a $1,500 to $2,000 job. I worked on a 2012 Honda CR-V last month with 176,000 miles. The owner replaced both air filters every 15,000 miles. The engine had no oil consumption. The HVAC system worked perfectly. I pulled the cabin air filter to show them what a properly maintained filter looks like. It had some dust, but the media was intact and airflow was still strong. Compare that to a 2014 CR-V with 98,000 miles where the owner never replaced either filter. The engine air filter was black and collapsing. The cabin air filter had leaves and debris packed in it. The blower motor was making noise. The engine was consuming oil. Both problems came from neglected filters. An engine air filter costs $15 to $30. A cabin air filter costs $10 to $25. You can replace both in 10 minutes with no tools. If you have a shop do it, they'll charge maybe $80 for both, including labor. Over 200,000 miles, you'll replace them maybe 13 or 14 times. Total cost is around $600. The engine wear and HVAC repairs you're avoiding start at $500 and can easily hit $2,000. Dealerships and quick lube shops do try to sell air filters, but they often do it in a manipulative way. They'll show you a dirty filter and imply your engine is about to fail if you don't replace it right now for 3 times what the filter costs. That creates distrust, so people stop replacing filters altogether. The correct approach is to replace them on a schedule regardless of appearance. That way you never have to decide whether the filter is too dirty. You just replace it at the interval. Fifth, spark plugs, and this one matters more than most people think. Modern spark plugs last a long time. Iridium and platinum plugs are often rated for 100,000 miles. Some manufacturers say 120,000 miles. The Japanese interval is much shorter. For most Toyota, Honda, and Subaru engines, the recommendation is 60,000 miles. Here's the specific recommendation. Replace your spark plugs every 60,000 miles. Use the exact plug specified in your owner's manual. Most modern Toyota and Honda engines use NGK or Denso iridium plugs with a specific heat range and gap. Do not substitute. Do not use copper plugs because they're cheaper. Do not re-gap plugs that come pre-gapped from the factory. Install them as they come. Spark plugs do more than just ignite fuel. They also act as a heat sink to remove thermal energy from the combustion chamber. As plugs age, the electrode erodes, the gap widens. That means the ignition system has to generate a higher voltage to jump the larger gap. That stresses the ignition coils. On most modern engines, each cylinder has its own coil. Those coils are not designed to operate at elevated voltage for extended periods. Once the coils start failing, you get misfires. A misfire dumps unburned fuel into the exhaust. That fuel heats up the catalytic converter beyond its design temperature. The catalyst substrate melts. Now your catalytic converter is clogged. The engine loses power. Fuel economy drops. And replacing a catalytic converter costs anywhere from $1,200 to $3,000 depending on the vehicle and whether it's a California emissions car. I've diagnosed more misfire conditions than I can count. The ones caused by worn spark plugs almost always have secondary damage. Failed coils, damaged catalytic converters, fouled oxygen sensors. It's never just the plugs by the time the problem is obvious. I worked on a 2009 Toyota Highlander with 162,000 miles and original spark plugs. The plugs were so worn the gap was nearly double the specification. 3 of the 6 ignition coils had failed. The catalytic converters were clogged. Total repair was over $2,500. If the owner had replaced the plugs at 60,000 and 120,000 miles, the total cost would have been maybe $400 for both services. I also worked on a 2010 Accord with 253,000 miles. The owner replaced the spark plugs every 60,000 miles. At 253,000, all 4 original ignition coils were still working. The catalytic converters were still efficient. That engine ran perfectly. A spark plug replacement costs around $200 to $300 at a shop for a 4-cylinder engine. More for a V6 because there are more plugs and they're harder to access. You can do it yourself for $60 to $100 in parts. Over 200,000 miles, you'll do it 3 times. Total cost is maybe $900. The ignition coils and catalytic converters you're protecting are worth $3,000 to $5,000 in repairs. Manufacturers extend spark plug intervals because it makes their maintenance schedule look simpler and cheaper. And most spark plug failures happen after 100,000 miles, which is outside the powertrain warranty on most cars. You're the one paying for the coils and converters, not them. 6th is brake fluid, and almost nobody changes brake fluid until something breaks. Brake fluid is hygroscopic. That means it absorbs moisture from the air. Over time, the moisture content increases. That lowers the boiling point of the fluid. It also causes internal corrosion in the brake calipers, wheel cylinders, master cylinder, and ABS pump. The Japanese maintenance interval for brake fluid is every 2 years regardless of mileage. Here's the recommendation. Change your brake fluid every 2 years. Use only the fluid type specified for your vehicle. Most Toyotas and Hondas use DOT3 brake fluid. Some newer models use DOT4. Subarus typically use DOT3 or DOT4. Check your owner's manual or the cap on the brake fluid reservoir. Do not mix DOT3 and DOT4 unless the manual specifically says they're compatible. Do not use DOT5, which is silicone-based and not compatible with standard brake systems. Brake fluid with high moisture content boils under hard braking. Once it boils, it creates vapor in the lines. Vapor compresses. Fluid doesn't. That means when you press the brake pedal, the pedal goes to the floor and the car doesn't stop. This is called brake fade, and it's dangerous and it's completely preventable. The moisture in old brake fluid also corrodes the internal components. Caliper pistons start sticking. That causes uneven pad wear and brake pull. ABS pumps fail. A master cylinder replacement costs $400 to $600. Brake calipers are $150 to $300 each. An ABS pump can cost $1,200 to $2,000. All of that comes from contaminated brake fluid. I worked on a 2007 Subaru Outback last year with 198,000 miles. The owner changed the brake fluid every 2 years from the day they bought the car. At 198,000 miles, the original master cylinder, ABS pump, and all 4 calipers were still functioning perfectly. I bled the brakes and the fluid came out clean and amber. Compare that to a 2011 Outback with 104,000 miles and original brake fluid. The fluid was dark brown, almost black. 2 of the calipers had seized pistons. The ABS pump was making noise. The repair was over $1,400. A brake fluid change would have been $100. Brake fluid service costs around $80 to $120 at a shop. Over 10 years, you'll do it 5 times. Total cost is maybe $600. The brake system components you're protecting are worth $2,000 to $3,000 in repairs if they fail. You won't hear this from most shops because brake fluid service is not a high-profit item, and most brake component failures happen gradually enough that customers just think, it's normal. Where? It's not. It's deferred maintenance. 7th is the engine and cabin ventilation systems, and this is something most people have never even thought about. Your engine has a PCV valve. PCV stands for positive crankcase ventilation. That valve lets pressure and blow by gases escape from the crankcase and recirculate back through the intake to be burned. If the PCV valve clogs, pressure builds up in the crankcase. That pressure forces oil past the seals. You get oil leaks from the valve cover gasket, the front and rear main seals, and the camshaft seals. It also pushes oil into the intake system, which causes carbon buildup on the intake valves. On direct injection engines, which most modern Toyotas, Hondas, and Subarus use, carbon buildup on the intake valves is a huge problem because there's no fuel washing over the valves to keep them clean. Here's the recommendation. Replace your PCV valve every 60,000 miles. It's a $15 part on most vehicles and takes 5 minutes to replace. On some engines, the PCV valve is integrated into the valve cover, and you have to replace the entire cover. That's more expensive, but it still needs to be done. If your engine has a PCV filter, replace that at the same interval. Clean your throttle body every 30,000 miles. You can do this yourself with throttle body cleaner and a rag. Just spray the cleaner on the throttle plate and the bore, wipe it clean, and you're done. If you have a direct injection engine, have the intake valves walnut blasted every 60,000 to 80,000 miles to remove carbon buildup. This costs around $300 to $500 depending on the shop, but it prevents misfires, rough idle, and loss of power. The PCV system is part of the emissions control system, but it's also part of what keeps your engine internals clean. A clogged PCV valve doesn't just cause leaks. It also lets sludge build up in the crankcase because the blow-by gases aren't being evacuated. I've torn apart engines with clogged PCV valves. The inside of the crankcase looks like it's coated in mud. The oil pickup screen is blocked. Oil starvation follows. Bearings fail. Once bearings start failing, you're looking at an engine replacement. I saw a 2013 Honda Civic Si with 118,000 miles 2 years ago. It was burning oil and misfiring. The intake valves were so carboned up they weren't sealing. The PCV valve was completely clogged. We had to walnut blast the valves and replace the PCV valve. Total cost was $780. If the owner had replaced the PCV valve at 60,000 miles and cleaned the valves at 80,000, the total cost would have been around $350 and the problem never would have happened. I also worked on a 2008 Toyota Camry with 267,000 miles, where the owner replaced the PCV valve every 60,000 miles and had the throttle body cleaned regularly. That engine had no oil consumption and ran smooth at idle. For a car with nearly 270,000 miles, that's uncommon unless the maintenance was dialed in. Replacing a PCV valve yourself costs $15 in 10 minutes. Having a shop do it is maybe $60 to $80. Cleaning a throttle body yourself costs $8 for a can of cleaner. Having the intake valves walnut blasted costs $300 to $500. Over 200,000 miles, the total cost for all of this is under $1,000. The engine repairs you're preventing, oil leaks, carbon buildup, valve damage, you start at $1,500 and can exceed $4,000 if the damage spreads. Nobody talks about the PCV valve because it's a $15 part that doesn't fail catastrophically. It just clogs slowly and causes problems elsewhere. By the time you notice, the damage is done. It's the perfect example of a maintenance item that costs almost nothing, but prevents problems that cost a fortune. Eighth is differential and transfer case fluid if you have all-wheel drive. Most Subarus are all-wheel drive. Many Hondas and Toyotas offer it. If you have all-wheel drive, you have a rear differential and possibly a transfer case. Both of them have fluid. That fluid needs to be changed. The manufacturer will often say it's lifetime fill. It's not. The Japanese interval is every 30,000 miles for severe use and every 60,000 miles for normal use. If you drive in snow, tow anything, or drive on dirt roads regularly, you're in the severe use category. Here's the recommendation. Change your differential fluid every 30,000 miles if you use your all-wheel drive system hard. Change it every 60,000 miles if you drive mostly on pavement in good weather. Use the exact fluid specified by the manufacturer. Subarus use Subaru Extra S gear oil in the front and rear differentials, and Subaru High Torque CVT fluid in the transfer case on CVT-equipped models. Honda all-wheel drive systems use Honda dual pump fluid. Toyota systems vary by model, but most use 75W85 gear oil in the rear differential. Do not use generic gear oil. The limited slip additives and viscosity modifiers are specific to each system. Differential fluid lubricates the gears and bearings inside the differential. It operates under high load and high temperature. As it ages, it shears down. The viscosity drops. Metal particles from normal gear wear contaminate the fluid. Once the fluid breaks down, the gears start wearing faster. You'll hear whining or humming from the rear of the car. That's the differential telling you it's starving. If you keep driving, the bearings fail. Once the bearings fail, the gears can seize. A rear differential replacement costs $1,500 to $2,500, depending on the vehicle. Transfer case failures are similar. I worked on a 2010 Subaru Forester with 212,000 miles last year. The owner changed the differential and transfer case fluid every 30,000 miles because they drove in snow every winter. At 212,000 miles, the differentials were quiet and the all-wheel drive system worked perfectly. I drained the rear differential and the fluid came out clean with just a little metallic shimmer from normal wear. Compare that to a 2012 Forester with 96,000 miles and original fluid. The rear differential was howling. When we drained it, the fluid was black and had chunks of metal in it. The differential was destroyed. Subaru wanted $2,300 for a replacement. A differential service costs around $100 to $150 per differential. If you have a transfer case, that's another $100 to $150. Over 200,000 miles, you'll service the differentials 3 or 4 times. Total cost is around $800 to $1,000. The differential replacement you're avoiding is $2,000 to $3,000. The reason this is labeled lifetime fill is because differential failures almost always happen after 100,000 miles and outside the warranty. It's also a maintenance item that makes the vehicle look more expensive to own. Removing it from the schedule makes the cost of ownership appear lower. You pay for it eventually, just later. Ninth is fuel system cleaning, and this is one people argue about. There are a lot of snake oil fuel additives on the market that do nothing. But there are also legitimate fuel system deposits that build up over time and affect performance. Modern gasoline has detergents in it, but they're not always strong enough to prevent deposits, especially if you use lower quality fuel or let the car sit for long periods. The Japanese approach is to use a high-quality fuel system cleaner every 10,000 miles and to replace the fuel filter on the schedule. Here's the recommendation. Every 10,000 miles, add a bottle of high-quality fuel system cleaner to a full tank of gas. Use a product that's been proven to work. Chevron Techron, BG44K, and Liqui Moly Jectron are all legitimate products with independent testing behind them. Avoid anything that makes outrageous claims or costs less than $10. If your vehicle has a replaceable fuel filter, which many older Toyotas, Hondas, and Subarus do, replace it every 60,000 miles. Most modern cars have the fuel filter integrated into the fuel pump assembly inside the tank. Those don't get replaced unless the pump fails, but if you have an external filter, replace it. Fuel injectors spray fuel in a precise pattern. As deposits build up on the injector tip, the spray pattern distorts. That affects combustion efficiency. You get incomplete combustion, which lowers power and increases emissions. It can also cause misfires. Carbon deposits also build up on the intake valves, especially on direct injection engines. Those deposits disrupt airflow and prevent the valves from seating properly. You get compression loss, rough idle, and misfires. A bottle of fuel system cleaner dissolves those deposits before they cause problems. I worked on a 2014 Toyota RAV4 with 134,000 miles that was misfiring and had a check engine light for a lean condition. The owner had never used fuel system cleaner and always bought the cheapest gas. I pulled the injectors and they were caked with deposits. We had to send them out for ultrasonic cleaning. That cost $320. If the owner had used a bottle of Techron every 10,000 miles, the total cost over 134,000 miles would have been around $120, and the injectors would still be clean. I also maintain a 2011 Honda Accord that I use for parts runs. It has 198,000 miles. I add a bottle of BG44K every 10,000 miles, and it runs like it has half the mileage. No misfires, no rough idle smooth acceleration. A bottle of quality fuel system cleaner costs $12 to $25. Over 200,000 miles, you'll use it 20 times. Total cost is around $400. Fuel injector cleaning or replacement costs $300 to $800. Intake valve cleaning on a direct injection engine costs $300 to $500. You're spending a little continuously to avoid spending a lot all at once. Most people skip this because they don't see an immediate result, but the result is what doesn't happen.